So far, we had created the attraction transaction to record the data of tourist attractions. Now we want to add to the attraction the category to which it belongs. For example, we want to categorize it as a monument, museum, historical site, etc. We will need a new transaction to represent the categories. We have to indicate the attraction transaction that every tourist attraction will have. In addition to an identifier, a name and a photo, a category, that is, only one of those that are registered in the category transaction. If this is the category transaction with these three categories entered, we will want that when we enter a new attraction. After providing the name and photo, we must provide a valid category for the attraction. That is, one of the existing ones. That is why we must enter the category identifier here. If we leave the value 0, we will get this error, which is the same as if we type an ID for which there is no category. In neither case will it allow us to save. This validation is being performed automatically. On the other hand, if we enter 2, the name of the historical site category is displayed, which is the one that corresponds as we saw in the category transaction. In short, in order to save the tourist attraction with the data on the screen, we must necessarily enter an existing category identifier. If we leave it empty or enter a non-existent ID, it will throw an error and will not allow us to save. This control is called referential integrity. Let's implement it. Let's start by creating a category transaction. We already know how to do it manually, so now let's try a simpler way, which is using an artificial intelligence assistant. We access it like this. Here we see this chat open, which prompts us to ask for something. This is called a prompt. So we type, create an entity to register categories, with ID and name. Let's see what it responds. The assistant tells us that it created the category transaction, with attributes category ID and category name, which is what we expected. And it leaves the newly created object open, unsaved, which is why we still don't see it in the KB Explorer. If we go to the Structure tab, we see those two attributes and their data types. We could have written the prompt in another language. Artificial intelligence works in any language. It's important to keep in mind that generative artificial intelligence does not usually respond exactly the same way to exactly the same request. Sometimes it may respond by suggesting a possible solution and asking us to confirm. Other times it may ask us for some additional information before continuing. Once the transaction is created, we can make any changes we want and save it. While we knew exactly how to manually create this transaction, doing it through the wizard saved us time. Let's see how the assistant can help us with something we don't know how to do yet, which is to relate transactions. If we want to continue making requests where it needs to remember what was discussed before, then we do it without deleting the chat. If we want to delete that context and start a new conversation, then we delete the previous dialogue. Let's ask the wizard to relate the attraction transaction with the category transaction in the desired way. The assistant tells us that to establish the relationship, it has to add the category ID attribute to attraction, and that this attribute will act as a foreign key referencing the category entity. Although we have not yet discussed foreign keys, it would seem that we are on the right track. We see that it added the category ID attribute to the end of the attribute list in the source. If we go to the structure, we see this, which is what we would have had to do if we hadn't used the assistant. That is, we close the transaction without saving it, so that the changes made by the assistant are not kept, and reopen it. Manually, we would have had to add category ID directly in the source after the last attribute, or through the structure, we see that it offers us to choose any of the KB attributes that start like this. We choose category id. Since that attribute already exists, we don't need to define its data type because it already knows it. If we go now to the Structure tab, there we see the attribute with that special icon, which is indicating precisely that this attribute is a reference to another entity. We already know that it is to category. If we now go to the attraction web layout, we see that the field corresponding to the category identifier attribute has been added. So now we will have to indicate for each attraction the category ID it belongs to. Since this is not very user-friendly, because no user is going to memorize the category IDs in order to know, for example, that if 2 is entered, it means the category Historical Site. It will be necessary to display the name of the corresponding category so the user can see its value on the screen. To do this, let's go back to the structure, and under the category attribute, add the category name attribute. Let's go to the layout, and now we will be able to see the name of the attraction category. If we look at the icons that GNexus added for each attribute that exists in category, we see that the one for category id shows an outward arrow, while the one for category name tries to represent that it receives that value from somewhere else. This is quite intuitive. This second attribute will be read-only. It will receive its value from the category name here. That's why we'll call it an inferred attribute. That attribute will not be in the attraction table. Since in the structure of the attraction transaction appears the category ID attribute that exists as the primary key of the category table, GNexus interprets that in attraction this attribute, which is identical in all respects to that of category, constitutes a reference to that table. We say that in attraction, then, it has the role of foreign key. If in the KB Explorer we edit the information of the attraction table, we see that it will contain all the attributes of the transaction structure, except for category name. This attribute will be stored in the category table, so that in the attraction transaction its value will be obtained by fetching it from the category table, through the foreign key in attraction. That's why we say it is inferred. By simply having placed in the attraction transaction an attribute that is the identifier of another entity, GNexus interprets this relation between entities and ensures the integrity of the data, achieving the behavior we saw at the beginning of this video, where the existence of the referenced record will be validated and the operation will not be allowed if it breaks the referential integrity. Subtitles made by the Amara.org community.